Hey guys, so today we have a camera filming a camera, hardy har har, but this particular camera doesn't turn on is what I'm told. Apparently they plugged it into the computer and took some files off it, and after that she was no dice, so bit of an odd thing to happen. We'll throw some batteries in it and see if we can prove that. So it just takes a couple of AA batteries. And what way do they go in? Looks like positive up that way. There we go. Let's hope these have got some charge in them. Power button on top. Right. Power button on top. There's the light. So I'm going to say no. Okay, so screws on this model, which is a Sony CyberShot model DSC-S730, and a few on the bottom there it looks like, one up underneath the battery cover, a couple on the side, a couple on the other side, and the whole thing will just fall apart after that, I'd imagine. They're fairly easy to get apart. Right, a couple of clips around the side. I find a fingernail works well to release those. There we go. What I'll do now is attach a power supply to the battery terminals just to make sure that there was enough power going to it. I don't know if those batteries are actually completely charged, and these cameras can require 3 volts at times. Your rechargeables are only 1.2, and even though they're full of capacity, these things will shut down thinking that the voltage is getting a bit low. So what I have for doing things like this are these little clips that go straight into my power supply, and when you squeeze the end you get a little hook that comes out, and you can hook onto hard to reach connections. We've got a couple of you can see the battery terminals come through here, so it's easy to hook onto them just to do a quick test like this. Right, let's hit the power button again. No, definitely nothing. So we have a couple of screws, one there, and that will let the screen come off the back and give us access to the main board. And it would pay to look at the board up on top where it has the buttons on it, and make sure that those buttons are working right as well. My mistake, the screen flips out of the metal bracket separately. The screws get the bracket off, and then we get access to the board. One thing I'll check for sure is that little battery there. When they go flat, they can cause all sorts of problems in smart devices. Anything that needs memory backup and whatnot. So we'll do that now. For those who are interested, we have a Zoran ZR36473 BGCF, which looks like the main processor, and a Chips CT47568 SR566. And I'm not entirely sure what that one does, but I'd hazard a guess at memory being a rectangular shape, but I could be entirely off track. We can Google that for the data sheet later. Now that battery is tested at 1.1 volts, 1.2 volts. I'm going to say it probably should be 3 volts, but I'm just going to do a bit of research on the number on it and see if I can't figure out for sure. Generally these little cells are 3 volt from my experience, so let's see if we can Google this number up. Okay, so looking at Mouse's website here, the closest number I can find is ML614S. It's got 614S stamped on the battery, so I think that's pretty safe to say that's the model we're looking at, which says there is a 3 volt cell. And I also had a look on Wiki here, and they've got a nice little table that says as far as coin cells go, lithium cells are generally 3 volts, alkali zinc cells, as you can see, about 1.5. So I'm fairly confident that this should be a 3 volt cell just based on the number alone, but I thought this table was interesting to note. So what I've done here is I've soldered a couple of wires onto the cell, and I'm just going to clip the bench supply onto it. I've limited the current to about 150 milliamps, so I don't think anything's going to go wildly wrong, but you never know. I'm pretty confident in the number on that cell as indicating it is 3 volts. So I'm going to clip that on there. Yeah, probably not a rechargeable cell, so that's why I've limited the current as well. We don't want to get that cell stinking hot and have a mess on our hands. So I'll clip the power onto that and put the batteries in and see if this thing turns on. Okay, now it's not drawing any excess current, so I'd better lift it off the deck, because if this does turn on, the lens is going to fire out at us. Oh, that doesn't look too flash at all. Right, there is another option here that that battery may need to be removed in order for it to clear its memory, so to speak. The fact that there's been a low voltage on there for some time, it likely might need that voltage removed to start over. So we'll pull the cell off and see what happens. Coin cell is removed, so let's hit the power button now and see what happens. Not much doing. Now I did test the battery voltage before and it did drop to 2 volts, so yeah, I might need to stick another supply on this. I don't actually have 1.5 volt batteries at the moment, so another option too that just came to mind is that with the back off, the function selection switch is not making contact, so it may not know what mode it should be starting up in. So I'll just try something there. I'll join 2 of the connections together that would simulate it being in a given mode. And that didn't work either. Let's make sure we can get 3 volts into this thing. Here I have soldered a little jumper wire from the center there, which is actually ground, to one of the connections that would simulate the switch being in that position. And you need to note, if you're going to do this, take care not to get any solder on the area that the wiper runs around, because that could be an issue with connection quality later on. It'll be really hard to get off, so best to leave the gold plating alone there. But I went right in the middle and the wiper goes nowhere near that. Let's power it on for another time and see what happens now. Well, the power supply is drawing 0.5 amp, but I've still got no power light, and there's nothing on the LCD. So something is working, but at this stage, hard to know. Let's see if anything's getting too hot. I mean, half an amp and something like this is it sounds like a lot, but I do know they suck the batteries. Yeah. Okay. You'll know I don't actually have 3 volts on the other line yet at the moment. My other bench supply only does 3.5, and I don't really want to put an extra half a volts on the input or on the memory battery at this stage. So that could be all of the reason, but I'll see what I can work out. Okay, for now I'm going to hang a larger coin cell off the end of it because it's exactly 3 volts, and that will remove any doubt that there's an issue with not having 3 volts on the line there. So one more time, huh? Yeah, that cell may not play much of a role in anything then. It's still not turning on, although it is drawing half an amp, so something obviously isn't too happy in there. I'll probe around some of these little voltage regulators and see if there's anything that looks like expected voltage, I guess you could say. You know, nothing that seems a bit silly like 0.3 of a volt. Yeah. Right, so what I'm seeing there is 1.7 volts and 2.7 volts is the only voltages coming off this. These individual switching regulators, and yeah, the fact that there is something there and it's relatively high, I guess, you know, if you're expecting 3 volts or 1.8, you know, it's almost near enough. But half an amp is quite a bit, and I'm wondering, when you first turn these on, they spit the lens out. Now, if the lens is jammed, there will be, I guess, quite a high current draw while the motor's trying to turn and can't. So my next step would be to check that. I don't know if it's jammed or what. It kind of feels like each section there is moving separately when I push on it. But it's somewhere to start. I mean, when you don't have a service manual for these things, you can only try one thing and then try another and see where it gets you. This connector that had the screen in it, that just flips up to release the cable. These two just pull straight out and push back in. And with the board flipped over, we can see that there's a connector there. It plugs into there, along with that flex cable. I think I can leave that connected for now. Just be careful pulling these flexes out and inserting them, especially. You don't want to tear them. They are very fragile. It looks like 3 screws hold the main lens assembly in place, but it is going to come out through the front. We're going to have to get the front skin off. I've undone the screws that hold the top of the power button there, the strip of plastic there. There was no screw in this end, but there was that pin just pushes in and also retains the carry strap, so that just pulls out. And with that top strip off, the front skin just comes away. Quick word of warning: in cameras that have flashlights, you will find a large high voltage capacitor. In this case, they've tucked it away in there behind the front cover there, and its pins are up the top here. It just solders on through there, and they've covered it in tape. Now, they can store, and I think it's around 400 odd volts or so, and they'll hold it for a long time. You might think the camera's been dead for days or weeks, but they could still have that charge in there. So you want to be careful opening these things, not to get your fingers across those pins at the base of the capacitor. At least check with a multimeter to make sure it's discharged, just to be safe. And with the other flat flex unplugged from the main board, the assembly falls out the front. So now what I'm going to do is find the motor connections. I'll stick some power on them and see if the motor spins, see if the lens moves in and out freely. If you were able to get to the motor connections with that flex cable still plugged into the motherboard, I highly recommend you don't put voltage on the motor. You don't want to backfeed up to the mainboard control. It may not like that. Yeah, so make sure that motors are always unplugged before you power them from another source. Now you can see two motors there in the top right corner. You can see the back of a small motor, and that one will either be driving focus or possibly activating the shutter, but I think shutters are usually just electromagnetically operated. There's no motor drive. So yeah, likely operating focus, and the large one there will be operating a gear arrangement around the outside of the lens to move the lens in and out for your zoom and such. So the large one is the one that I'm going to be testing at the moment. Now I've got the wires attached, and in this this operation you want to be careful. There's a chance you can strip gears very easily because of they're very geared, and there's a bit of torque able to be applied. So this has sensors in it so that the motherboard knows that which end of the extension it is. So it will stop it, of course, but doing this, it's got no control. So you need to be very careful, and I've put the power down to 2 volts, even though it may be driven with 3, and I've limited the current to a couple hundred milliamps. So and what I'm going to do is just quickly flick the connection onto the wire and listen and watch, of course, and just make sure that it's not trying to pull in, because if it is, we need to reverse that. If you keep going, it'll likely strip teeth on gears. Right, well, I had them the wrong way the first time, so we'll give this a shot. Yeah, it looks pretty smooth. And you saw it pull in slightly toward the end and then come out again. That's indicative of quite a few of these small cameras. They all sort of do the same movement. So you want to take the power off when you see that happen. You know you're almost at the end of the run. So we'll reverse the power here and suck it back in. And of course, when the shutter shuts, that's all the way in. And it was only drawing milliamps, so as far as I can tell, I think that's okay. The other thing that can go funny in these is the positioning sensor. But I mean, it usually comes on anyway and tries and throws an error message. So the fact that it's not coming on at all and there's no display, yeah, it could be a bit more serious. We'll pop this back together and keep looking. I'm having a bit of trouble feeling this connector click into its socket, even though the board is right in position. So I'm just going to pop something underneath it to give it a little bit more lift. And make sure that that seats correctly. So I've just popped a small piece of this double-sided foam tape under there. It's spongy, so it has a bit of give, which will allow it to support itself and not be too pushed up into the main board. We don't want to cause the board to flex up in the middle when we screw it down. Right, now we're getting somewhere. I thought half an amp was a bit much, and I was poking around with my finger looking for hot spots, and there it is. That little black device there is getting incredibly hot, enough to melt the solder, such that it has shifted on its pads. You can actually see the legs are not sitting nice and perfectly center in the pads anymore. Like everything else is. I would say that's what's happened. So I need to figure out if it's that itself is faulty, or if maybe there's an overload after that. If it's some voltage regulator, there may be a short circuit after that which is overloading it. So let's do some more probing. There's definitely a short circuit coming off of this device. The top right pin comes out into the capacitor, just to the bottom right of it, the large brown block there, and that, yeah, that's the positive side of the capacitor, which is measuring about an ohm to ground, which is not good. Now the two transistors at the bottom, those three-legged devices, or three pins rather, there's no legs on them, they measure okay. So at this stage, I'm not too sure what that feeds yet, but I have seen these surface mount capacitors go short circuit. So I'll pluck them off, is probably the easiest thing to do first, and see if the short remains. If it does, we'll have to trace this through until we find where it ends up, and go from there. Yeah. Okay, what I'm seeing between the output pin here and ground is a resistance of about 1 ohm. If I go directly to ground, it's 0.4. It's a dead short. Basically the meter lead resistance, but there's a definite slight resistance difference on the positive side. So when I'm probing around trying to find out where the positive side is going, I know that if I see 1 ohm, then I'm on the right path. If I see any less than that, then I know I'm just probing the ground point, which it's shorted to. So I have removed those capacitors. It made no difference, so I'll pop them back on. And there was a very tiny one there. You almost can't see it with a naked eye. Yeah, I've traced the positive rail through to this connector, which goes up to the top board with the power button on it. And that's well, it may go other places. I've probed around the CPU, these capacitors and so on. Nothing coming up as yet, so we'll unplug the top board and see if the short goes away. It may just be up on top there. Well, that has proved rather fruitless. So what I've been doing is with one lead of the ohm meter on there, the positive rail there, and the other lead I've just been running around components listening for the beep, which is real handy if you have a meter that beeps. If it beeps on only one side of the component, then I know I've just got the ground side. If it beeped on both sides, then that would indicate that's directly feeding that particular component. In this case, it looks like it runs to the main processor, the RAM, and up to the top board, of course, through that flex. And I think it even ran down to the camera, the lens mechanism, and also over to here, which is likely the LCD. So it's certainly quite involved in everything. Yeah, it's probably a short in the main chip or something. That's all I can put it down to. I mean, yeah, without plucking every component off the board that it goes to, chances are it's done something nasty there. As I said, they plugged it into USB to get pictures off it, and it wasn't happy from there on. So it could have been a disagreement with the USB voltage rail versus its own battery and whatnot, but seriously not happy. I will leave it at that. Hopefully some of my thought process will help you guys repair your own products. I'm sure I could have done it in a more efficient manner. I mean, I was looking for hot spots around here. I just happened to miss the very edge of the board where that one was, so I could have gone down that route a lot earlier, but hey, you got to see inside a camera, and a couple of methods I use for checking things. See you next time.